What a lovely piece of iron oxide this is. Stick around to see how we replace it with something a lot more shiny. Somewhere here is where the exhaust is going to be. And to get rid of the somewhere and be a little bit more exact, we're going to lower the cab and take some measurements and form what's called a plan. I think a plan might be a good idea for this. Let's lower the cab. Maybe need the thing. Before we get into the build, I want to save the workload of some of the YouTube certified engineers. No, I'm not a welder. No, I'm not good at welding stainless steel. And no, I will not be back purging the welds. I don't have the equipment, the time, nor the money to make the setup. If the welds were before the turbo, I'd be a lot more inclined to back purge the welds. That's all. Thank you. With the cab down, we can now see exactly what sort of space we have here for the silencer muffler system thingy. Now, for shits and giggles, I do need to start the engine without the muffler. So yeah, I'm just curious of what it's going to sound like and what level of dampening we need. So this is purely scientific. Nothing to do with me being a little lad that wants to hear noisy things. Not at all. We've done a bit of research on what we can do to the frame and stuff, and we did that in the house, and then we come out to the truck and then we realized that this is not a place where you can actually drill into the frame. I made some notes here, Blue Peter style, and you cannot drill within 25% of the top or bottom. You cannot drill in the top and bottom. So within 41.25 millimeters you can drill. You can make holes at a maximum of 15 millimeters diameter, and they need to be minimum of 50 millimeters apart horizontally, lengthwise. But you might see that there's a plate on here, and there's also something called a gearbox behind here, and various other things, including some cross members and things. Basically it means that this section here is pretty much no bueno when it comes to actually drilling stuff or mounting stuff here. I'm sure you could do it, but you'd probably be best off taking the gearbox and cross members out and things like that, and no, we're not doing that. The blue mark here is where the cab ends, and the other blue mark is 70 millimeters further back, which means that that is the distance that is needed between the cab and the habitat box. This doesn't really matter down here on the frame, but it would be nice if the exhaust would finish in style with the cab. It also means that any potential flex of the whatever is built here or hung here is not interfered with the exhaust. So the exhaust is supposed to be in here somewhere. We're now trying to determine what size, width, height and shape the box is going to be. We've also figured out that according to the Euro 3 manual, this is not a Euro 3 vehicle, you need 200 millimeters between any plastic or a brake or electrical or any kind of sensitive wiring or cabling. That's quite a lot. With a heat shield it's 80, with heat shield and extras it is 40. This is about 40, so a little bit further away from that. Now that's on a Euro 3 or Euro 4 vehicle, I believe, and those have catalytic converters and other things like that, so they run the exhaust a lot hotter. They also have AdBlue and various other things, I think. So I don't think it applies that much to this vehicle, but still we need to be mindful of having the wires here, and naturally the cab is above us, so we don't want too much heat transfer into there either. So the likelihood is that the top and the side might have a heat shield or several parts, but I think they need heat shielding. So to conclude, no drilling in front of this, probably attached to the step, but again we need to keep in mind that the cab tilt mechanism needs to be here. Luckily there's a lot of space up there. The part here is actually a lot lower than up here, and there's also a lot of space into there. When we started the truck without the exhaust on, we noticed that it's not that loud, so I don't think the silencer muffler needs to do that much of hard work. I think we now need to do some CAD modeling and determine where we're actually going to attach the silencer. The material we bought for the exhaust and silencer is 4 sheets of 750 by 500 by 1.5 millimeter stainless steel sheets. We have 2 of these tubes that are outer diameter about 76 millimeters. They're 750 millimeters long. We've got a perforated one that is 500 millimeters long, and then we've got 4 90-degree bends. We have 2 flex joints. We have 4 flex bolt thingies, rubber thingies, and then we have 2 V-band clamps. Right, and Patch, what do you reckon? From this we're going to try to fabricable an exhaust that is quieter than without exhaust.
Right, we've got a plan. No weights, I think we're just going to kind of wing it. So anyway, our current train of thought is that we're going to make a bracket here, and a bracket here, and an uppity thing here, and a downity thing here, and we're going to mount the exhaust box in this kind of area here, and we've chopped down the existing exhaust pipe and put it there just as a template and kind of know where it's going to come out of the engine and out from under the truck, and that's where we are at the moment.
We have now made 2 brackets. Here's one. It's a very simple angle iron with 2 holes in it. This one is not much more elaborate. It's a flat plate with an angle iron welded to it. We thought we took a measurement that the blue line was where the cab is, but I think we might have had a bit of a wonky stick to measure that one with, so I think we're about 17 millimeters off. Now when we know that the muffler silencer is going to be between this one at the front and this one at the back, we need to start doing some CAD work. I think doing the CAD work, also known as cardboard aided design, is absolutely essential, at least for me. My brain just can't process things far into an abstract future. I need to see how things work and look in real life. The CAD model reveals a lot of things, such as space available, possible mounting solutions, potential obstacles, and finally the looks. The process is quite simple. Cut some cardboard up to the dimensions you think are correct, trial fit, cut stuff off, or add more cardboard. Keep iterating until you've got a shape or a product that you're happy with. In between each iteration, there's a lot of talking, pondering, looking, measuring, talking, pondering, looking, etc, etc, etc. This part of the development process is cheap. Don't rush through this step. Yesterday's work resulted in this beautiful CAD template that goes something like this. Hello. Let me put this CAD file away. We're quite happy with the shape of it, and I think we're going to go with that one. However, there's a problem that we need to correct. When we did the measurements yesterday, we measured this blue line to be the back of the cab and this blue line to be the front of the flatbed. There's the 70mm gap that is required between them, and all things were pretty tickety-boo. I made this bracket that fits on there, and that front edge pretty much follows the blue line. The problem is that this blue line is pretty much 17mm, give or take a few millimeters, too far back. And that means that if I would use this bracket and then have a box that comes out along this line, then that box would stick out from behind the cab. And that basically would look like a drawer isn't closed. If the drawer is in under the cab, or exhaust in this case is under the cab, then that looks okay. Even if it's 10mm, 20mm, it would look okay. But if it sticks out 10mm, I think it would look really odd. Which means I need to remake this bracket to start off with. And that reminds me of that old saying, measure once, cut once, weld once, cut off once, measure once, weld once, and then you have the perfect piece. The first thing I'm going to do today thus is to redo this bracket so that it doesn't make the box stick out from under the cab in that direction. I cut this angled piece off, and I am going to just replace it with another same piece of material as this one. I need it to be about 90. It'll be about 50 when I'm done, but I'll cut off 10mm there, and then this will give me the surface to attach angle irons for the brackets. Enough ranting, let's just weld these together. The new part of this plate is now welded on, and I have made a sticky out bit here that's going to sit on the side of the silencer. The next thing I'm going to do is I'm going to weld this in here, and then probably some bit of reinforcements and things like that too, but at the moment that's what's going in. So let's clamp it up and fuse it together. The rear bracket is on the truck, and I've welded it together, and it's looking quite good. It's still not finished, but it'll do for now. This is the front bracket, so I'm going to weld a tab onto here, and this tab prevents the exhaust from going too close to the frame. And it's not necessary for actually holding it in place, but it's very useful for me when I'm building it, so that every time I take the muffler silencer off, it'll be in the same spot. So keep in mind, if you're making things that need trial fits tens, hundreds times, that you put devices or measures in so that everything goes in the correct spot whenever you work with it, because you don't want to drill holes in the wrong place or things like that. So just a small tip. The sturdy squares that you see me using are from Fireball Tool. Jason and his troops have a variety of squares that are extremely useful when fabric cobbling. You'll see me using them throughout this project. I highly recommend them, and just for transparency, I have no affiliation with Fireball Tool. With the two brackets in place and the CAD model visualized here in virtual 3D space, we can now have a look at the front bracket, which has had very little modifications to it. The only thing I've done to it is I made a stop on the back, which you'll see in a second. The rear bracket, on the other hand, has now got the sticky out bit, as I showed you, and it's also got a stop bit. Let me take this bolt away so that you can see the brackets better. There's the stop for the front bracket, and there's a stop for the rear bracket. If I pull on this one, there's a bit of flex in this direction. It's okay for now whilst building it. We'll see how heavy it all turns out to be, and then probably end up making a triangulation here and probably one on the top too. The next step, I think, is going to be to extend this bracket out to the same distance out as the rear one. That means that we will have at least 2 mounting holes on each side of the box, and that means that we can position the box accurately every time. We don't want to get that wrong. This is the rear bracket, and this is the same flat bar that I used to make this one from. The front bracket is made from this angle iron so far, and that doesn't fit. So because I suffer, or actually enjoy, a little bit of tartism, I'm going to make it out of a taller bracket, and then I might have to shape it so it looks pretty. Yeah, I'm not sorry about that at all. I usually don't do self-promotion unless it's for narcissistic reasons, but this time I'll make an exception. There are several long videos about how I made this adjustable and foldable welding table. Go check it out if you want this kind of awesomeness in your life too. Links in the description as per YouTube custom. The front bracket is now welded up and I've drilled the holes. Hopefully they will align with these holes. Yeah! Seems right. And now I'm going to scribe this one so that we can shape it and make it pretty. I'm using a large M8 washer to get the roundiness of the end of the bracket. Then I'm simply scribing a straight line to the bottom of the bracket closer to the fastening points. And after a bit of quality time with the rotary eraser, this is what they look like dropped on the table. Or even better, this is what they look like mounted on the truck with the CAD model imposed using virtual reality. After we finished filming and working yesterday, we took the brackets off. One thing I didn't do was measure the distance between the front bracket and the rear bracket, because that distance gives us the back part of the box, which is the one that we need to bend and fold in that way. So I'm going to put the brackets back on so that we can measure that, and then we need to start thinking about how we make the actual box.
Every engineer will be familiar with the saying, "Well, it fitted on CAD." To try and ensure a right first time quality standard, here I am translating the measurements from the CAD model into J-code. A great deal of time and attention here will ensure that the 3D 5-axis fabric cobbler machine will produce an accurate representation.
Here you see us working on a very abstract piece of artwork. We wanted to show the audience the feeling we get when we use metal cutting power tools. A weird coincidence was that the artwork turned out to be perfectly suitable to use as cut lines for the silencer box. We decided to use them as such and deprive the art world of our creativity.
Ooh. Wow.
This is my shop built sheet metal folder. I built it earlier this year and it's based on a 100 by 100 mm angle iron. It was built to do exactly this, build the exhaust, boxes and perhaps even tanks such as water or fuel. After I built it, it was put on the floor without any paint or other finish. Naturally, it had developed a bit of a rust layer. The big angle grinder with the big brush made quick work of the minimal tidying needed. Then it was time for us to figure out how to actually use the folder. I had only done a test bend or two before, so this was crunch time. As you saw, we've cut the sheet metal out. This is going to be towards the front of the truck or the back of the truck, and this is going to be half of the center bit of the silencer. The other half is on the other piece for two reasons. The primary reason being that we don't have a big enough sheet to make this out of one part, and the second is that we can now adjust the width to perfection because we have left a little bit extra material on that edge, so they'll currently go like so, and then we can cut off the excess and weld them together so it'll look perfect. Nobody knows that there's a seam in there unless you tell someone. Don't tell people about that stuff. Now we have then fished out the rusty hunk of metal that is the sheet metal bender. I filmed this, but I haven't made a video, so if you want to see how it was made, let me know. What we've then tried to do is we've tried to figure out how sharp the bends are going to be. I can adjust this clamp in or out depending on how much space I want between the edge and the edge of the clamp. And this is what we've come up with that looks to be a good bend radius for the exhaust silencer box. What we then have tried to figure out is where does the actual bend happen in relation to the actual mark, and this was how it was marked, like that. And basically where the mark is, that is the clamped part, and then the bend happens outside of that, which makes sense if you think of it. So now we've figured out that we need to clamp this part so that we get a bend like that. That's what we're hoping for. We have no idea what we're doing, so I'm sure it'll be fine. A little too much, but too much is better than anything. Just after we removed the first piece, we realized that we'll need to do exactly the same bend on the second piece. What we should have done was to clamp a stop block at the back of the bender before we did the first bend. We tried to do it retrospectively, but you never get the same precision as if you would have done it before the first bend. And with our inexperience, we decided to do it without the stop block and just try our best. The two tank pieces are now clamped up here on the table. The table's flat, and the reason for clamping them down here is to check if they're actually the same. And if you can see here, that's the discrepancy. So I think that one was about 2.3 millimeters and about 1.8 here in this location here, and those are pretty much spot on. And on the other side here, again spot on, no problems. Yeah, so up there, that's the discrepancy there. So we're pretty pleased with that. And the next step is to see if we can fit them on the truck and see how much we need to cut off of this edge here. This here is the rear side of the exhaust box. This is the center-ish side of the box, or half of it. And now we have the rear bracket here clamped to the table with this square, and the sheet metal is clamped with this square, which means that now we have been able to draw the line here where the bracket sits and mark the two holes. With these two holes marked and drilled, we can then screw this on the truck, and that gives us a level line at the bottom and the top, which should then match up with the other half of this, which should then match up with the bracket, and then we could drill the holes in that panel referencing the bracket, and then we might have a box-ish shape on the truck. This is about where some overcautious decisions cost us quite a lot of time. We put the two panels between the brackets and marked a line. In theory, it should have been simple to divide that distance in half and then cut both panels, and they would fit perfectly. However, we had a measurement, and we decided to make a bit of a jig on the table and then fit the panels in the jig. But now we had two measurements. Which one was the correct one? The organic fitting to the truck, or the more sterile fitting on the table? Keep watching to find out. Hopefully you saw on the time-lapse that we tried to fit the box and we weren't really happy with it. Initially it looked like it fit really well, but then upon closer inspection it was a bit wonky. And I believe the wonkiness is because the rear mount, which is here, and the front mount, which is here, are not on the same plane, and therefore if the box is too wide it skews the box in this direction. So I think the next step is to use the rotary eraser and remove a little bit of material to see if we can get it a little bit more level. Because we're only talking about millimeters here, we can't use the circular saw to cut it, so just, yeah, angle grinder a little bit here and there. After about 1100 times of grinding the two mating parts of the back of the box, or the center part of the box, we're now happy that they fit together in there. Then we marked out the bracket on the side here, and unfortunately it's not super square, so we are now taking the bracket off the truck, that is the front bracket. I'm going to put it on here to see exactly what's going on, because it might be that this was a bit skewed, a bit of flex, so we want to see if we can figure it out before we just go and drill holes in a wonky place. It might be okay as is, but let's just double, triple check or something. It's finally there. The holes we made here in the front seem to have actually aligned and worked really well, even if we took a little bit of a gamble on that the box was sagging a bit when we were marking the initial holes. But now, once we corrected for that, it seems to sit really well. This back line here is parallel with this one, which was one of the things that I wanted to have. And then yeah, so the back bracket, front bracket, all seems to work really well. The next step is to try to get rid of these, and I think that we can do that by actually giving this a couple of tack welds there and make it into one piece. We've got the two parts laid out on the table here with a stop here, so hopefully we get a straight line on the top there. And first we're going to tack weld them, probably then turn it around so I can weld it a little bit from a better angle, a better position. But that's the plan right now. And just like that, the front piece and the back piece are now one piece, and it still fits. Amazing. I have no idea what the next step is going to be, but there's going to be one. With a few days off working and doing some editing, I think I have had my brain finally come to the conclusion that the next step is to do the actual exhaust pipe that connects to the muffler from the engine, that is. I've been debating on whether I should raise the cab or not so that I get more access, but as I'm being lazy at the moment, I think I'm going to try without raising the cab and see if I need to do it later. And as it happens, I've got a template here, so I don't have to make things up. All I need to imaginate is the last bit, how it connects to the box at the end. So I think the first thing to do is to remove that rusty hunk and take it into the workshop and see what we can do there. This is the tube that goes onto the engine on the truck. The inner diameter here is 80 millimeters and 84 millimeters outside diameter with a 2 millimeter wall thickness. It has been enlarged in this area, and the rest of the tube is 80 millimeter outer diameter. This tube that we bought is slightly smaller, about 2 millimeter or so smaller. It's got, let me check, around 74 millimeter inner diameter and around 77 outer diameter. The wall thickness is 1.8. The reason why I'm saying that it's about this or that is because the tube isn't actually perfectly round, it's actually a little bit oval. So anyway, my problem was that with the 1.8 millimeter increment in wall thickness, it's very difficult to make steps to make it fit these ones. And what I mean by that is that I had hoped to cut a piece of that tube off and then basically put it around this tube and thus grow the circumference of it so that it would fit here. But with the diameters that they are and the wall thicknesses as they are, this makes it a very difficult proposition, because if it would be 1 millimeter wall thickness or 2 millimeter, it would be a lot easier, but it's not. So I was racking my brain a lot about this, and at some point I said to myself, if I had one tube that was same as this one, then I could shrink it onto this one, like basically do pie cuts at one of the ends and just cut off a little bit and shrink it that way. And I thought, well, I can probably take this tube and get a length of it and then cut it, and that way I can enlarge it and then fill the slit, the gap there, with something else. So I'm going to try that. I hope that makes sense. I'm sorry for the waffliness of this, but my brain's a little bit overworked. Anyway, let's try this. Cut a piece of that, make it fit this one. Yeah, let's try that. Here's now about 120 millimeter length of that tube, and this is the offcut from the exhaust. That is the same as on the truck, and I'm now going to try to make sure that this tube can go over it instead of inside of it. I'm going to start by cutting a slit down the side, and then we'll see where that takes us. With the slit cut in the tube, I have it now clamped around the exhaust pipe from the Mog. I put a 1 millimeter spacer at the bottom, and then I used some hose clamps. I had to use 2 to extend into 1. I used 2 sets of those to clamp it onto here. Then I marked out the gap, which is 25 millimeters here, and the length of it. So I'm going to cut that piece out, and then I'm going to hopefully put it underneath there and tack it, and then with a little bit of luck I can actually get this off. And if I can then fully weld it, then I think we have the problem primarily solved. The 1mm spacer is down at the bottom, and now there's a rudely and roughly beaten piece of stainless steel in here. It doesn't fit super well, but I hope that it's well, it's tight there, maybe a little bit too tight. That's probably what I'm trying to say. And I'm now going to tack it on, and then I'm going to try to get it off here. If I can't get it off, it's a little bit of a bummer really, because then I'd have to weld this piece to the truck, and then that kind of... Anyway, let's tack it on and see what happens. It looks a bit rough, and it took a little bit of persuasion to get done, but all in all it doesn't look too bad. So I'm going to fully weld this now and hope that it still fits once I've done that. But yeah, this might work. There it is. No, that's the side there. It doesn't look too bad. It'll do. I don't know if you can see in there. Probably not. But my point is that it sort of fits on here. And that means that I've now wasted probably about 3 or 4 hours doing this. So I'd recommend you to buy the proper sized tubes. Anyway, with this one done, I think we can now try to fit this onto the next bit. That wasn't a total disaster. With the expanded pipe and the standard size pipe that I have, the gap is a little bit too big. One way of making this smaller would be to cut slits in it and then squish it at the end and then weld it onto there. I think it'll be a little bit stronger and better if I take another piece of the same tube, again with another slit in it, push this over there, and now the fit for this one is not too bad at all. I think it is tight enough to actually weld onto there. With the expanded tube welded to the standard tube, we should now have a tube that fits the tube on the truck, i.e. same as this one. The next step is to fit part of this bend here to mimic this bend here. Initially, I started out by measuring the angles of the bends on the original tube, but that turned out to be a waste of time. I quickly figured out that an organic method of copying the bends were a much better approach. As this was the first time I've ever worked with pre-bent tubes and making an exhaust, a lot of my brain capacity was used to figure out how and where to measure what. Then the rest of the brain capacity was used to figure out how to clamp it all to make it accurate, but still with good access to the parts that I needed access to. I did enjoy it though. Let me explain this weird concoction on the table here. First of all, on the truck we measured the distance of how far this pipe goes onto the pipe that's on the truck, and it goes actually 120 millimeters, but it looks like it has been 100 millimeters. I made my new pipe to comply with the 100 millimeters, but I also noticed that depending on how far the pipe goes onto the truck, there's a little bit of play, and I might need that play because I might put a flex joint on a spot where there isn't that much space. So that's why I put 25 millimeter spacers in here. So now I have 75 millimeters here for the clamping and the connection between the truck and this exhaust pipe. Then the next part is that I clamp this square to the table, and I put this bend on here, and I put another square on the back here. It doesn't fit with the two pipes in, but basically like that. And that allowed me to see where on the back here the bend stops, or where it starts, where they meet. And that allowed me to slide this tube back and forth, and then I put this square on there. So now I know that this square, where this square is, I need to cut off this tube. So I'm using that square to measure that one, and then I'm using this square to measure how much of this bend we need to cut off. And I think I have it under control, but I've never done this before, so I'm a little bit nervous, especially with cutting expensive stainless steel tubes. So yeah, I'm sure it'll be fine. As you saw from the time lapse, I put the old exhaust pipe here, and then I put the squares here to hold it in place and get the angle right. Then I put these ones here to make the bend stop and register towards that. And now I've spent a little time making sure that the fit is fairly good. Let's put some tack welds on. managed to get it tack welded. Let's hope it's strong enough for a test fit tomorrow. Because it's 10 to 9 now, so time to quit the shenanigans for today. In the video, a few seconds ago I was working on this one. In reality that's 2 days ago, and now I'm going to continue with it. My aim for today is to get a pipe in a box. And what I mean by that is that if we can extend this to about that length, that means that the next step is to marry up the exhaust silencer box with the exhaust pipe. But yeah, so 2 more bends and more stuffs today. Hopefully that'll work out. More of this bendy lark. Now I need to figure out how to clamp the pipes to add the second bend. And this isn't as easy as the first bend because I already have a bend on the tube and the tubes aren't the same diameter either. This felt kind of like playing a jigsaw puzzle mixed with Lego Technics parts, where some parts fitted and worked well together, some didn't fit at all, and some I had to make into my own parts. There was a lot of back and forth with how I was going to clamp it all down to make sure I got a good result. If you're ever considering doing this sort of fabric hobbling, I highly recommend a flat welding table that you can clamp onto. It makes things so much easier. If my memory is somewhat functional, I think I've seen various tools and jigs that you can use to get tube bends done accurately and quickly. If I do this again, I'm going to have a good look for more tools. For example, a simple tool that allows you to score a bent tube perfectly would be a great help. Tape doesn't just have that same accuracy for some reason. Once everything is clamped up and you have the parts cut to rough dimensions, it's time for the patience game. No, not the card one, but the one where you run to the sander and you sand a fraction off the tube and then you go back and trial fit it. You see that it doesn't fit and you ask yourself, can I get away with it? Your inner perfectionist shouts, no! And you grab some more patience and head back for the sander. You repeat this process so many times that you don't even notice a global pandemic has passed. Then suddenly it fits. There are no gaps. Bliss. Now what year was it again? Several hours later, we have a bend and a tube tacked onto the other tubes and bends. Let's go see how it fits on the truck. Well, at least it looks like it is somewhat in the correct direction. Let's mount the box, or the 3 sides of the box, and see how close we are and what we need to do next on here. With the tube here, the exhaust here, I checked what bends I have, and I have two of the offcuts from the 2 bends that are on the exhaust. Sadly, neither of them are suitable for this, but this is roughly a good thing here, right like that. The plan I have devised, therefore, is that I will cut the straight bit of this one, which is to about there, and then I will tack weld the V-band onto this one and onto this one. Then that should give me an entry to this box pretty much as far as I can to this edge here. So I'll save a little bit of space with that one there. So cut this one, then tack some V-bands on, and we will reconvene here later. As I said, I would take the straight bit of the bend. It does make sense, trust me. But then I also discovered that I can take this much of the exhaust. By taking this much off the exhaust, the entry to the box, which will be this piece, will now come closer to the front of the truck, therefore saving that much weight and also space. There is no need to go towards the back of the box if the box is already there. Now with these two pieces out of the way, we can now focus on this piece. This is a V-band clamp, and it's the evolution of the dreaded slip on a tube onto another one and then put a horrible U-bolt clamp on it. The V-band clamp is actually pretty neat. You just undo this bolt here and loosen it a little bit, and then you can flip that thing off up there, and then you can move this along the tube, and then these two pieces are welded onto each end of the tube. They have a little bit of a raised bit there, which means that you can locate it like that, and then this thing you just goes on there, and your stock of useful curse words has remained intact. With all that waffling, it is now time to weld one of these onto here and the other one onto there. Welcome to the underside of the truck. As you can see, shiny exhaust is here. I've clamped it in place with a 20-ish millimeter spacer up here so that it doesn't get too close to that, and that it now stays in place so I can work on it without it changing its mind every time. I have also put a 20 millimeter-ish spacer here to protect it from the frame. The next step is to remove this piece of material here on the box and to extend the exhaust into the box. One thing I just realized is that this tube is probably going to enter this panel with more than half of its diameter, and that means that my initial plan of just cutting a large piece off here and then just wiggling this one up and down and cutting off a little bit, little piece by piece, isn't going to work, because then the bottom of this tube would be leaving a gap there. Maybe it's acceptable, I don't know. It feels a little bit like I should not be doing this, but we'll see. Let's see where we end up.
One of the things I hate about stainless steel is drilling into it. You need a lot of pressure on the drill, but at a very low speed, so you don't heat up the workpiece and drill too much. The moment the stainless steel work hardens, your drill is basically dead. Due to the high pressure, I find it very hard to use a hand drill. A drill press is much better. However, I was astonished how well the Bosch hole chewed through the stainless steel sheet. Plenty of coolant and a bit of patience was all it took. Superb. Then it was time to make the round hole a little bit less round so that the inlet pipe could fit into the box at an angle. This job would have been really annoying without the new angry end, also known as the die grinder. With a sharp bit on the end, this was a joy. Well, except for all the stainless steel glitter that I was covered in. After about 647 trial fits, it fitted like a glove that didn't fit that well.
Okay, now we have a hole in the back of the box where
this thing fits into, like so. Right, so the next thing that I'm going to do is I'm going to tack this onto the tube, and then I'm going to mark it at the back there, or the front even, so I know where to weld it, and then I'm going to call it a day, because it's already 6:30 and it's Saturday.
This is where we'll end this part of the exhaust build. I'll get straight on to editing the next episode, so hopefully it will be out very soon. I'd like to thank all the subscribers, new and old. Thank you for joining the shenanigans. We hope that you stick with us and that we'll see you in the next one. Thanks for watching.